Ready? Welcome student. Welcome to Core Academy. I am Ashish. Today I will discuss with you the Bayes theorem part 2, which is mainly problem based. I have already discussed a video. I made a video on Bayes theorem part 1. You first view that video because it will clear your concept, and then you view the Bayes theorem part 2, this video. So let us go now direct to the classroom. Come. First problem. There are 3 coins. One is two-headed coin, that means both side head. Another is biased coin, that comes off head 75% of time, and third one is unbiased. A coin is selected at random. A coin is selected at random. Out of these 3 coins, a coin is selected at random and tossed. If it shows head, what is the probability that it is two-headed coin? So this problem will be solved on application of the Bayes theorem. So according to the Bayes theorem, let us first do 2 events. Let's A be the event of selecting coin, and B is head appearance. So first we have to make a chart. Left side we will show the event A where the total probability is 1. Suppose there is a 3 coin. What is the probability of selecting the coin? Suppose probability of selecting first coin A1 equal to, out of 3, 1/3. Probability of A2 is also 1/3, and probability of A3 is also 1/3. So see, total is 1. Always for applying Bayes theorem, you make a chart and take the left side, the event, where you will see that the total probability of the event must be 1. And now I am taking right side. Right side means if the coin 1 is selected, what is the probability of head appearance? That means probability of B when A1 occurred. Probability of head when first coin is selected. If the first coin is selected, if it is two-headed, that means both side head. So what is the probability of getting head? Is 1, because both side is head. So this equal to 1. And probability of this of head when we select the second coin. Second coin, what is the probability of getting head? Second coin, when second coin is selected, since it is a bias coin, the probability of head is 75%, that is 3/4. And if the third is selected, it is an unbiased coin. So probability of head when third coin is selected is half, because it is biased coin, one side head and one side tail. The probability of which is half. Now, according to the Bayes theorem, what is required? According to the Bayes theorem, it is work that a coin is selected at random and tossed. It shows head. It shows head. So it shows head. This is the given condition. It shows head. So according to the Bayes theorem, denominator would be probability of B, sigma probability of B. That means what is the probability of head when A1 is selected? What is the probability of head when A2 is selected? When probability of head when A3 third coin is selected. So this into this, this into this, this into this will be the denominator. That will be the sigma probability of B. The probability of B. You can say probability of B. This is the probability of B. The probability of head appearance. And in the numerator, what is required? It shows head. What is the probability that there is two-headed coin? So two-headed coin means A1. So you take this branch as numerator. So in the numerator, I have to write just what is required. There is space shortage. Actually, what is the question asked? It is shows what is the probability that it is two-headed. So probability of two-headed, that means A1 when B occurred, that means head occurred. So how will you calculate? First you flip this, that means probability of B when A1 and multiplied by probability of A1, and numerator would be probability of B. So probability of B, so for the probability of B, this into this, this into this, this into this, simple apply this. That means 1/3 into 1 plus 1/3 into 3/4 plus 1/3 into 1/2. Always take the denominator, this into this, this into this, this into this, and above what is required, that it is two-headed. So since this one is two-headed, so take this branch. So numerator it would be 1/3 into 1. So the answer would be 4/9. You will be able to calculate this fraction to answer it. So first, what would be our effort? First, take the event A and B, A1, B1, T1. Sum of the probabilities must be 1. Take those probabilities in the left hand side. And now the probability B, when B means the event head occurred when A1 is selected, note it down. Then in the numerator, denominator, you multiply this into this, plus this into this, plus this into this. And the numerator, what is asked? What is the probability that it was double-headed? It was two-headed. So two-headed branch is this one. Take this as a numerator. But the problem will be solved. But if the question asked, what is the probability that the probability of head? What is the probability of head? So this portion, this into this, this into this, this into this. That means this portion is the total probability of the head. Some question asks, what is the probability of head? So probability of head means when A1 is selected, head, A2 is selected, head, A3 is selected. So you multiply this denominator, sum is the probability, total probability of head. That is total probability or probability, totality of the probability. Clear? Second problem. A speak truth 8 out of 10 times. Out of 10 he speak true 8 times and 2 times false. He says false. A die is thrown. He has to report whether 6 arrives, 6 appears, whether 6 appears or not. If he reports 6, what is the probability that it is actually 6? You read the question twice, 3 times. So let P be the probability that he speaks true. So probability of A is 8/10, that means 4/5, and probability of speaking false, A complement, is 1 minus 4/5, that is 1/5. How much total? Total is 1. See, so always take left side whose probability is 1. Now it says that a die is thrown and he has to report whether 6 or not. So what is the probability of 6 when a die is thrown? A die is thrown, the probability of 6, I take probability of 6 B. So probability of B when A has occurred, when he speaks the truth. So when he speaks the truth, the probability of 6 would be 1, 2, 3, 4, 5, 6, 1 by 6. In throwing a die, probability of 6 is 1 by 6. And therefore, A speak the truth and the probability of appearing 6 is 1 by 6. And the probability of speaking false 1 by 5th. What is the probability of reporting 6? Reporting 6. He says false. And if it does not appear 6 and he speaks false, then he will report 6. Understand this. He appearance 6 does not appear. 6 does not appear and he speaks false. That means what is the reporting? 6 does not appear. 1, 2, 3, 5 appears. 6 does not appear and he speaks false. So what would be the reporting? 6 does not appear, he reports false. That means he speaks false. That means what would be the reporting? Reporting would be 6 because 6 does not appear and he speaks false. No, so negative, so though he will report that it is false. 6 appears because 6 does not appear and he will speak false. So he will report 6. So what is the probability of B complement? What is the probability of B complement when he speaks? When if he speak false is 5 by 6. He speaks false and 6 does not appear. 6 does not appear and he speaks false. So what would be the reporting? Reporting would be it is 6. So what is asked? If he reports 6, so report 6. So what is the probability of report 6? This into this plus this into this. That means 1 by 4 by 5 into 1 by 6 plus 1 by 5 into 5 by 6. That means here he speaks true and 6 appears. Okay, and here he speaks false and 6 does not appear. So reporting would be 6. So this is in whole the probability of reporting 6 as numerator. And what is there? So it reports 6. It is denominator. What is the probability that it is actually 6? Actually 6 in which case? This was actually case. He speaks the truth and head appears. 6 appears. So take this branch as numerator. So 4 by 5 into 1 by 6. So probability is equal to 4 by 9. You will be able to calculate. Third problem. An insurance company insured 2000 scooters and 3000 motorcycles. The probability of accident of scooter and motorcycle are 0.01 and 0.2 respectively. An insurance vehicle met with accident. It was given condition. A insurance company vehicle met with accident. What is the probability that it was motorcycle? So it is application of Bayes theorem. So first let's probability of A1 is the probability of that the insured vehicle is a scooter. So out of 5,000, 3 plus 3, 2 plus 3, so 2,000 is scooter. The probability that an insured vehicle is scooter is 2 by 5. And so the probability of insured vehicle be motorcycle AP2 is 3 by 5, 1 minus 2 by 5 or 3000 by 5000, total C 1. So now it is given that the probability and the probability of accident of scooter, if it is a scooter, so probability of accident, that means probability of accident if it is B, so if it is a scooter, given scooter equal to 0.01, and the probability of accident when it was a motorcycle A2 is equal to 0.02. So now what is the probability a scooter, a insurance vehicle met with an accident? So if I say what is the probability that the insured vehicle met with an accident, it is the given condition that insurance vehicle met with accident. So what is the probability that the insured vehicle is in accident, met with accident? So if it is a scooter, then what is the probability of accident? This, that was scooter and accident. So it is multiplied, scooter and accident, and it is motorcycle and accident. So what is the probability that the vehicle met accident? This into this plus this into this, which will come as denominator. What is the, if there may be some problem where it will be asked what is the probability that a vehicle is met with accident, that means total probability. If it is scooter, what is the probability of accident? This into this. If it is motorcycle, what is the probability of motorcycle and accident? This into this. So what is the probability of accident? This into this plus this into this, which will come in the denominator. So according to the Bayes theorem, what is asked? Probability of, it is motorcycle, probability of A2 when accident occurred, when B occurred. That is how, first flip this, B by A2, probability B by A2, and multiply it by denominator P, probability of A2, divided by probability of B. So you see, probability of B means the vehicle met with an accident. This into this plus this into this. So denominator is very easy. 2 by 5 into 0.01 plus 3 by 5 into 0.02. And now numerator, what is asked? That it is a motorcycle. So where is motorcycle branch? This. Because accident occur and motorcycle. This. And this would be my numerator. So 3 by 5 into 0.02. So answer is Answer is 3 by 4. Answer. You will be able to work out. Clear? Fourth problem. Two groups are competing for the board of directors of a company. In a company, board of directors positions will be selected. So there are two group A, group B, or like A1, A2. They are competing for the group of directors positions of a company. The probability of winning first group and the second groups are 0.04 and 0.06 respectively. See, the sum is 1. That means it will come left side. The first group wins if first group wins, the probability of introducing a new product. If group 1 is selected, the probability of introducing new product is 0.7, and that of the second group, if second group is selected, the probability of introducing new product is 0.3. Find the probability that new product is introduced by the second group. That means it is given that new product is introduced, and what is the probability that it was introduced by the second group. So I make chart A winning of the group. Suppose probability of A group winning is 0.4, and the probability of winning second group A2 0.6. See, sum is 1. And what is the probability of introducing new product? B event. I consider it as B event. B is the event of introducing new product. So what is the probability of new product if first group is selected? 0.7. And what is the probability of introducing new product if second group is selected? Is 0.3. So chart is clear. Left side is 1. Now first, what is asked? What is the probability that the new product is introduced? It is given. So that means it will come as denominator, and it was introduced by the second group, that means A2. So it is required probability of A2 given that B occurred. That means it was given that it was introduced. What is the probability that it is introduced by the second group? So according to the Bayes theorem, according to the BAYES Bayes theorem, this is equal to first flip probability of B by A2 into probability of A2 divided by probability of equal to 118 by 146 equal to 9 by 23 answer. Fifth problem. A card is lost. One card is lost from a pack of 52 cards. From the remaining that means from 51 cards, 2 cards are drawn at a time and found to be both diamond. Both are diamond. 2 cards are drawn and it is found, it is observed, it is given that both are diamond. Find the probability that lost card was also diamond. So first, in a pack of cards, 1 card is lost and then 2 cards are drawn at random and it is found, observed that both are diamond. Then what is the probability that the lost card is also diamond? So it is also Bayes theorem. Now take the chart. The probability is that the lost card, 1 card is lost. So 1 card is lost. What is the probability that it is a diamond? Because there are 52 cards, 13 diamond, 13 club, 13 spade and 13 heart. So there are 13 cards diamond. So probability that the lost card is diamond is 13 by 52 is 1 by 4. And the probability that it is not diamond is 3 by 4, and total you see 1. Left eye okay. And what is the probability that when 2 cards are drawn, both are diamond? When lost card is diamond. When lost card is diamond, that how many remaining diamond? 12. So in how many ways 2 diamond card can be selected out of 12? Because one diamond is lost. So 12 C2 and the remaining card was, if one card is lost, 51. So in how many ways 2 cards out of 51 is selected? 51 C2. You will be able to calculate 12 equal to 12 into 11 by 51 into 50. Now you see second, 2 cards are drawn and there is probability that both are diamond when the lost card was not diamond. So if lost card was not diamond, therefore 13 diamond cards were there. So in how many ways 2 cards can be selected out of 13? 13 C2, and total number of ways in which 2 cards is selected, 51 C2. So this is the lost card. We assume first lost card is diamond. So 2 card can be drawn out of 12 diamond card is 12 C2, and total number of ways 51 C2. And if the card is not diamond, so then 2 diamond card would be selected out of 13 C2 by 15 C2. This equal to 13 into 12 by 51 into 50. Okay. Now according to the Bayes theorem, this into this plus this into this is the total, the probability of the 2 cards being diamond, that will become in the denominator. So 1 by 4 into 12 into 11 by 51 into 50 plus 3 by 4 into 13 into 12 by 51 into 52. This is the probability of 2 cards being diamond in both cases. Either it is diamond, lost card is diamond, or not diamond. Now, what is the probability that lost card is diamond? The lost card is diamond, that means I want this branch as numerator. So 1 by 4 into 12 into 11 by 51 into 50. You simplify, LCM would be same. 4 into 0.15, 51 into 50. After simplification, we will get result 11 by 50. That means 0.22 is the answer. Here, this into this as numerator. What is the probability of A when B has occurred? So it will first flip. So what is the probability? B by A and into probability of A. Probability of A being multiplied. Clear? Sixth problem. The probability that a student comes to college by train, different mode of transportation, train, bus, scooter, car, are 1/3, 3 by 10, 1/5, 1/10, 2 by 5. There are different students. The probability that a student come, these are the probability they come by train, bus, car, scooter, and car respectively. The probability of late. What is the probability of late if they come by train, bus, scooter? Are 1 by 4, 1/3, 1 by 12. However, if they come by car, he is not late. A student is found to be late. So this is the given condition of Bayes theorem. Conditional probability that a student is found to be late. What is the probability that he comes by train? So A is considered, A even is coming by vehicle. So probability of A1, I am solving. Probability of A1, that means train, 3 by 10. Probability of bus 1 by 5, probability of scooter 1 by 10, and probability that it comes by car is 2 by 5. So what is the probability of late if they come by car? If they come by train, 1 by 4, that means probability of B, event B is late. What is the probability of late when it comes by train? Is given 1 by 4, and it is bus late 1 by 3, and probability of late when he comes by scooter is probability b by a3 is 1 by 12. However, if he come by car, he is not late. The probability of late when he come by car is 0 because he is not late. Okay. And now what is asked? A student is found late. So if I ask what is the probability of late, this into this plus this into this plus this into this plus this into this is the probability of late. So it will become in the denominator, and we will select the numerator branch. A student is, what is the probability they come by train? Train this one 3 by 10. So it will be the numerator. So what is the probability a student come late, and what is he comes by train? The probability of A1 when he is late, when B given B has occurred. So B has occurred. In numerator we take this branch 3 by 10 into 1 by 4, and numerator 3 by 10 into 1 by 4 plus 1 by 5 into 1/3 plus 1 by 10 into 1 by 12 plus 2 by 5 into 0. Okay. So 3 by 10 into 1 by 4, this gives answer 1 by 12. So 1 by 12 is the probability that he comes by 10 given that he was late. And what is, if you ask what is the probability of late, you add this on entire denominator is the probability of late. So it is the given condition, to divide it, because this is equal to, you flip it, probability of B when A has occurred into probability of A1. You see this branch 1 3 by 10 and B by A 1 by 4. Clear? Last problem. In a village 80% are smoker, so 20% are non-smoker. Probability of lung cancer of smoker is 10 times. Probability of lung cancer among smoker is 10 times of that of non-smoker. So probability of smoker having lung cancer is 10 times than that of non-smoker. If the probability of lung cancer in the village is 41 by 1250, find the probability of lung cancer of smoker. Probability of lung cancer of the smoker. Here there are two parts. What is given? Total probability is given. The probability of lung cancer when they are smoker and when they are non-smoker, we have to consider both. So let the probability A1 and A2 be the event of smoker and non-smoker. So probability of A1 80% who smoke, 80% means 80 by 100, 4 by 5, non-smoker 1 by 5. See 1. And the probability of each is not given. Probability, that means it is probability of event B when A1 occurred, and it is probability of B when A2 occurred. A2 means non-smoker. Probability of lung cancer when there is smoker is 10 times, suppose, and probability of lung cancer when there is a non-smoker is, suppose, X. Because we don't know X, we have to calculate probability of lung cancer of smoker, but total lung cancer probability is given. So the probability of, say, lung cancer when he is non-smoker is X, and probability of lung cancer when he is smoker is 10 times, that is 10x. So what is the total probability of lung cancer in the village? So lung cancer probability is total probability, that means probability of lung cancer. Probability of lung cancer when they are smoker and when they are non-smoker. That means this into this plus this into this. So 4 by 5 into 10x plus 1 by 5 into x. Therefore it is 41x by 5 equal to given 41 by 1250. So x equal to 41 can cancel, x equal to 2 feet, 1 by 1 by 250. 1 by 250 x. So what is the probability? What is the probability that the lung cancer of the smoker? Find the probability of lung cancer of the smoker. That means we want this lung cancer of the smoker. Probability of lung cancer when they are smoker, 10x. So 10x equal to, so 10x equal to, so find the probability of lung cancer, 10x equal to 10 into 1 by 250. That means 10 by 150 is equal to 1 by 25. So 1 by 25 is the probability of lung cancer of the smoker. Then last part, a person is found to have lung cancer. A person is found to have lung cancer. So what is the probability that he is non-smoker? Which branch we want? Which branch we want? It is known that he has that lung cancer given. The lung cancer given, that means probability how much given? It is 41 by 250. And what is the probability that he is non-smoker? Which branch we want? We want this branch as numerator. He is lung cancer and he is non-smoker. So in that case, the numerator probability of, we want probability of lung cancer is given. What is the probability that he is non-smoker? That means we want here a person is selected at random and found to have lung cancer. What is the probability? That means given probability of A2 when given lung cancer. So this equal to probability of B when A2 has occurred into probability of A2. Probability of A2. Probability A2, probability A2. This. So this equal to whole divided by probability of B. Is it? Probability of this equal to, you flip it and then probability of A2 will be multiplied divided by probability of B. Probability B is given on 41 by 250. And this one numerator, this branch, that he is non-smoker. That he is non-smoker. So that means 1 by 5 into x. X means 1 by 250 and numerator and denominator 41 by 1250. It is equal to 1 by 1250 divided by 41 by 1250. That means 1 by 41 is the answer. So from after this I conclude the two videos on Bayes' theorem. You visit, you view the both one, first for idea and some problems, second was based on problems. I think you will like both the video and you will share the video for more and more circulation, for more benefit of the students. You circulate, you share it to your friends, relatives, so that my purpose of making the video is successful. Thank you very much for watching my video.